Imagine a world where computers can solve problems in seconds. These problems would take classical computers billions of years. This is the promise of quantum computers. They harness the strange laws of quantum mechanics. This allows them to tackle incredibly complex challenges. These challenges are beyond the reach of even the most powerful supercomputers today. But this power comes with a price. Quantum computers could crack the codes that protect our digital world. Quantum computers don't use bits like classical computers do. Instead of bits, they use qubits, which are fundamentally different and far more powerful. While bits are like tiny switches that can be either on or off, representing a 1 or a 0, qubits can exist in multiple states at once. This unique property is what gives quantum computers their incredible potential. Bits are like tiny switches, either on or off, representing 1 or 0. Quantum computers use qubits. Unlike bits, qubits can be in a state of 1, 0, or both simultaneously. This phenomenon is known as superposition, and it allows quantum computers to process a vast amount of information at once. Qubits can be both 1 and 0 at the same time. This is called superposition. Imagine a coin spinning in the air not yet landed on heads or tails. That's a qubit in superposition. This ability to be in multiple states simultaneously is what makes quantum computing so powerful. Think of a coin spinning in the air, not yet landed on heads or tails. That's a qubit. This superposition allows quantum computers to perform many calculations at once, exploring multiple possibilities simultaneously. It's like having a supercharged version of a classical computer. This lets them explore many possibilities simultaneously. In classical computing, each calculation must be done one after the other. But with quantum computing, many calculations can be done at the same time, drastically speeding up the process. It's like having billions of computers working in unison. This parallel processing capability is what gives quantum computers their immense processing power. They can solve complex problems that would take classical computers years or even centuries to solve. This unlocks immense processing power. Quantum computers can tackle problems in cryptography, optimization, and simulation that are currently beyond the reach of classical computers. They have the potential to revolutionize many fields by providing solutions to problems that were previously thought to be unsolvable. Already, quantum computers are making strides. Researchers and scientists are using them to develop new materials with unique properties, design life-saving drugs, and even improve artificial intelligence. The possibilities are endless, and we're just beginning to scratch the surface of what quantum computing can achieve. They're being used to develop new materials. By simulating the behavior of molecules at the quantum level, scientists can discover new materials with properties that were previously unimaginable. This could lead to breakthroughs in everything from energy storage to superconductors. They're also helping to design life-saving drugs. Quantum computers can model complex biological systems, allowing researchers to understand diseases better and develop more effective treatments. This could revolutionize the pharmaceutical industry and lead to cures for diseases that are currently incurable. And they're even improving artificial intelligence. By providing the computational power needed to process vast amounts of data, quantum computers can enhance machine learning algorithms and lead to more advanced AI systems. This could have a profound impact on everything from autonomous vehicles to personalized medicine. The power of quantum computers lies in their ability to mimic the quantum world. Unlike classical computers, which use bits to process information, quantum computers use quantum bits, or qubits. These qubits can exist in multiple states at once thanks to the principles of superposition and entanglement. This allows quantum computers to perform complex calculations at unprecedented speeds. Our universe operates on quantum principles. At the smallest scales, particles behave in ways that defy classical physics. They can be in multiple places at once, and their properties can be linked across vast distances. This strange and fascinating behavior is what quantum computers aim to harness. This makes quantum computers ideal for simulating natural processes. By accurately modeling the quantum behavior of molecules and atoms, scientists can gain insights into complex systems that were previously out of reach. This capability opens up new possibilities in various fields of research. Take drug discovery, for example. Developing new drugs is a complex and time-consuming process. It involves understanding how different molecules interact with biological systems, which requires extensive experimentation and testing. Developing new drugs is a complex and time-consuming process. Traditional methods can take years, if not decades, to bring a new drug to market. Researchers must sift through vast amounts of data and conduct numerous experiments to identify potential candidates. Quantum computers could speed this up significantly. By simulating molecular interactions at a quantum level, they can quickly identify promising compounds and predict their behavior in the human body. This could drastically reduce the time and cost associated with drug development. They could simulate how different drugs interact with the human body at a molecular level, or consider material science. Quantum computers could revolutionize this field as well. By modeling the quantum properties of materials, scientists can design substances with specific characteristics. Quantum computers could help us design entirely new materials. These materials could have properties that are tailored for specific applications, such as increased strength, lighter weight, or enhanced durability. The potential applications are vast, ranging from aerospace to consumer electronics. These materials could be lighter, stronger, and more durable than anything we have today. The advancements in quantum computing hold the promise of unlocking nature's secrets, leading to innovations that could transform our world in ways we can only begin to imagine. Our digital lives rely on encryption. Encryption scrambles information. This makes it unreadable to anyone without the decryption key. Current encryption methods rely on complex mathematical problems. These problems are difficult for classical computers to solve, but quantum computers are different. They could crack these codes with ease. This poses a significant threat to our cybersecurity. Imagine a world where hackers could access bank accounts, steal sensitive data, or even shut down critical infrastructure. This is the potential danger of quantum computers if we're not prepared. Section 5. A world turned upside down. The implications of this are far-reaching. Imagine a world where hackers could cripple financial systems with a few keystrokes. Imagine them holding critical infrastructure hostage. Hospitals, power grids, even traffic lights could be vulnerable. The world as we know it relies on secure communication and data protection. Quantum computers threaten to shatter that foundation. This isn't just a problem for governments or large corporations. It affects everyone. Your personal data, financial information, and online privacy could be at risk. Section 6. The quantum threat to global security. The threat of quantum computers is not just theoretical. These powerful machines have the potential to revolutionize many fields, from medicine to finance. However, they also pose significant risks, particularly in the realm of global security. It's a global security concern. Quantum computers can break traditional encryption methods, making sensitive data vulnerable. This could compromise everything from personal information to national security secrets. Governments and organizations worldwide are aware of the potential risks. They are not sitting idly by. International conferences and collaborations are being held to address these challenges and to find solutions. They are investing heavily in quantum technologies. This investment is not just in the development of quantum computers but also in the infrastructure and talent needed to support this emerging field. This includes the development of quantum computers themselves. These machines, with their immense processing power, could solve problems that are currently unsolvable with classical computers. But it also includes research into countermeasures. Scientists and engineers are working tirelessly to develop new encryption methods and security protocols that can withstand the power of quantum computing. This has led to a new kind of arms race. Unlike traditional arms races that focused on physical weapons, this race is about technological supremacy. The goal is to achieve quantum dominance. Countries are vying for dominance in this emerging field. The stakes are high. The nation that leads in quantum technology will have a strategic advantage, potentially reshaping global power dynamics. Whoever controls this technology will have a significant advantage in the future. The race is on, and the world is watching closely as this quantum revolution unfolds. Section 7. Adapting to the quantum era. But there is hope. Researchers are working on new encryption methods. These methods are designed to be resistant to quantum attacks. This is known as post-quantum cryptography or quantum-resistant cryptography. These new algorithms are designed to be secure against attacks from both classical and quantum computers. Transitioning to these new standards will take time and resources, but it is essential to safeguarding our digital future. We need to start preparing now. Section 8. The Global Quantum Race. The development of quantum-resistant cryptography is a global effort. International collaboration is essential to ensure a secure digital future. Organizations like the National Institute of Standards and Technology, or NIST, are leading the way. They're developing and standardizing post-quantum cryptographic algorithms. Governments, research institutions, and technology companies must work together. We must share knowledge and resources. This is the only way to stay ahead of the curve. Section 9, the quantum future, a double-edged sword. Quantum computers represent a new era of computing. They have the potential to revolutionize many fields, but they also pose a significant threat to our cybersecurity. As we venture further into the quantum realm, we must be mindful of both the opportunities and the risks. We must invest in research, develop new technologies, and adapt our security measures. The future is coming. Let's make sure we're ready for it.